Okay, today is Tuesday. We'll take notes today. Have a homework assignment. We'll take notes tomorrow. Have a homework assignment. Thursday notes, Friday notes. Okay? Like I said, each lesson will be shorter than in the recent past. Okay? And then we will take the chapter 11 test on Monday. So what I'll do, yes, you will have a homework assignment Friday. I'll give you that and the chapter 11 review. The chapter 11 test is not going to take an hour and a half. So we'll have time at the beginning of class Monday to talk about some questions and go over some things before we take the test. Okay? Now, I will need to collect books on Monday. Because we have book assignments the rest of the week, if you have a physical book and you're not actually using it, feel free to turn it in before Monday so I can just get that out of the way. If you have no idea where your book is, let me know now that that's going to be an issue, and I can let you know how much the replacement cost is in case you cannot find it. Okay, so everyone needs to locate their book today so that A, you can use it for your homework, but B, if you don't have it, we can try to figure out where it is. All right, so we're going to be talking about the three-dimensional coordinate system. Lately, we've been graphing in 2D, X and Y being our two dimensions, okay? So now we're adding a third dimension, Z, okay? What's happening is we have the X-axis shooting out at us, the Y-axis going, well, in my picture, kind of horizontal, okay? And then the Z-axis is what is shooting out, like north-south, okay? So what happens, okay? We no longer have 4 quadrants. How many spaces do we have when we look at all of our planes? 8. We have 8 spaces, so we call them octants, okay? So let's talk about a couple of things. We have 3 axes, x-axis, y-axis, z-axis, okay? Which means we have 3 planes separating the space into 8 octants. Okay, so what I want you to imagine right now is that we're going to sit, like this classroom is our positive octant. So the floor is what would be like the XY plane, okay? This wall right here where the board is, this would be the YZ plane, okay? And then this wall over here would be that XZ plane, okay? So like this, like the corner along here would be the Y-axis. Along the bottom there would be the X-axis, and then this corner going up would be the Z-axis. Okay? Hello. Okay. Is somebody else in her room? Mm-hmm. Okay. Then I would look. How about you email her right now and ask her where she is? Okay. Yes.
So on this picture, which one is which?
Okay, so on the picture, it's a little bit different. Just pick which one you want to go up and down. And so the x-axis is shooting like straight out here. It's a little bit more to the left. Okay, does that make sense? Like this would be the x-axis, this would be the y-axis, this would be the z-axis. Okay. We need to be able to plot coordinates. That's what we're going to work on a lot today, and name the octants. Okay. So I'm going to show you a short video, and we will rewatch it, but we need to name the 8 octants. I will tell you, okay, when we're talking about x-y axis, quadrant 1 is where x and y are both positive. Would you agree? Okay. We're going to translate that to our octants. Octant 1 is where x, y, and z are all positive. Okay, so I'm going to show you this little video. It's not like super fabulous. It's just something that I found this morning that I thought could help. Okay, So here is where X, Y, and Z are all positive. Can you kind of orient yourself here?
At ZX plane, divide space into 8 octants.
Okay, I'm going to rewind. We're going to watch that again.
Space into 8 octants.
Okay, so 1, 2, 3, 4. Notice how when we did that, I'll watch it again, it's going to go in that same pattern as 1, 2, 3, 4 if we were just in like the XY plane. Like it follows that same counterclockwise motion.
Into 8 octants.
So 1, back 2, over 3, up 4, and then 5, 6, 7, 8 follows all underneath of those. Okay, so 5 is directly under 1. 6 is directly under 2. Okay, we're going to watch it one more time. 1, 2, 3, 4, then 5, 6, 7, 8.
Here.
In your book, there is a nice picture of it if you need to reference as you're doing your homework, okay? But we're always going to start with the most positive, and we're going to go counterclockwise, 1, 2, 3, 4. Under octant 1 is octant 5, and we just follow that same pattern, 5, 6, 7, 8. Okay? Now, we will get some more practice with the octants as we graph them. Okay. We're going to graph these 2 points. So give me a moment to make my X, Y, and Z axis. So yours looks like this, right? Okay. So this right here is positive X, this is positive Y, and this is positive Z. Okay. So our first coordinate is 3, 0, 0. X is 3, and then we don't move any in the Y or Z direction. So we just gonna go out 1, 2, here we are right here. 3, 0, 0. Okay. Now, can we say that this lies in an octant? No, because it's on an axis. Okay. So we can describe that this is on the x-axis. We could also describe that this lies in the xy plane. We could also describe that this lies in the xz plane. Okay, but we cannot say that it lies in an octant. Okay. All right, I guess that is it. Let's talk about 404. Okay. What's interesting about graphing three-dimensional coordinates is, have you ever drawn something, and if you look at it one way, like it looks like it's popping out at you, but if you look at it another way, it looks like it's popping back. Okay? We kind of have to be careful with that. We can't just like plot a point and it's just like floating somewhere. We have to really map out where that point is so our eyes can put it into perspective in our space. Okay? So 404. So we're going to go 4 in the x direction. 1, 2, 3, 4. But then we're going to have to, we have nothing for the y direction, but then we have 4 in the z direction. So what I'm going to ask that you do is that you follow these grid marks. So here is x is 4, and then if we go up 1, 2, 3, 4. Well, if I put it there, it looks like it's on the y-axis. But if I make a little dust trail, if you will, we can imagine that popping up from the x-axis into the xz plane. Okay? So since there is no y value, this coordinate is lying in the xz plane. You okay, Eli?
Yep.
Okay. Okay. Do those 2 points make sense with your eyes? All right. These are the next two that we are going to plot. Okay. So now we have coordinates that have non-zero values for all three x, y, z. So what I'm going to ask that you do is we're going to create kind of like a parallelogram with the x, y coordinate, and then from the corner of our parallelogram, move that up or down the z value. Okay? So this coordinate right here, 2, -3, 5. Okay? We need to go 2 in the x direction and -3 in the y direction. Okay? So here's a +2 in the x direction. We're going to go negative on the y-axis. And then what I'm going to ask you to do is I want you to make a parallelogram. Okay? Then, from that corner of the parallelogram, we're going to move up or down the z. So since we have a +5, we're going to move up 1, 2, 3, 4, 5 in that z direction, once again, leaving that trail, that dust trail. Okay, now, we have 8 octants. I want you to discuss at your pod which octant you think that this lies in.
Yeah. Yep.
All right, Callie, what do you guys think? Okay, octant 4. Do you guys agree with Callie and pod 6? Okay, remember the octants, all positive starts here at 1, back 2, over 3, up 4. Octant, very easy to say quadrant, right? Octant 4 is where x is positive, y is negative, and then z is positive. Okay? Octants 1, 2, 3, and 4, z is going to be positive. 5, 6, 7, 8, z is going to be negative. Okay? So let's plot -2, 6, 2. Okay? Actually, how about you try to plot this one on your own, and then we'll see how yours looks compared to mine. Make a parallelogram with x and y, and then leave a dust trail up or down. So x is negative, y is positive, So there's our parallelogram. And then from that corner, we need to go up 2. So there's our coordinate. Tiger, which octant is that?
2.
Good, that is octant number 2. Questions about plotting points? Okay. Last topic of discussion, yes, last topic of discussion, is the distance formula. If I wanted to know the distance between this point and this point, is it possible? Definitely possible. Okay? Who can tell me what the distance formula is if we're in 2 dimensions?
Square root of x2 minus x1 squared. It's like y2 minus y1.
Any ideas on what it would be in 3 space?
No.
Yep. Okay. We are still applying the Pythagorean theorem to make this distance formula, but what's happening is one of our legs of the triangle is like in an XY plane, and then we have the height of Z, and so when you make the Pythagorean theorem, you end up getting this. Are those just your notes for the day? That piece of paper.
Save paper.
Oh, okay. So that's excellent. So these two are over here talking about slope. How the heck do we find slope? Okay. We actually, what we're going to do here on Thursday, we're going to use vectors to describe slope because we can't have 3-dimensional slope. Okay. Instead, we're going to use vectors. And that's going to be kind of our way to describe slope. Okay. All right. So we're going to find the distance between these 2 points. Does it matter which coordinate you take first? It does not. Okay, just stay consistent. All right. So if these are your 2 points, we're going to take 2 minus 4 squared because those are our x's, plus 1 minus 1 squared, those are our y's, plus 6 minus 9 squared, those are our z's. Noah? Okay.
Yeah, we did really good on the test last year.
2 minus 4 squared? 1 minus 1 squared? 6 minus 9 squared. So our distance is the square root of 13, and I'll ask that you just leave it like that.
Wait.
No.
You guys didn't have a test over there.
Okay, we're going to do one short activity for you to just practice these coordinates and octants, and then I'll give you the remainder of the time to do your homework.